So we are going to discuss a topic of probability here. All right, let's just start. So probability is a measure of how likely an event is to occur. So let's just try to understand this definition with the help of an example. Like in our daily life, we use the phrases just by looking at the weather. We say um, it might rain today, or sometimes we say, okay, India may win a match today, or we can use the phrase, I might go to the college today. So you see, in all these events, there is involvement of uncertainty. Some kind of uncertainty is there. Like we are not sure whether that event is going to happen or not, whether it is going to rain or not. We are not sure. Like let's say we can say it is 50-50 chance, 50% chances are there it might rain today, or 50% chances are there it might not rain today, right? So that measurement of degree of uncertainty, that is defined by the probability theory, or we can just say that probability measures the degree of uncertainty regarding the happening of an event, or uh, it tells the possibility that what are the chances of occurrence of an event. Okay, another example we can take here is when you toss a coin, right? Uh, Either we are going to get head or we are going to get tail. Again, we are not sure. So, this is again, this uncertainty can be measured with the help of probability. Then we have another example here, like when you throw a dice. Again, it may or may not show the number 6. Again, we are not certain about that event. So, all these uncertainties, they are defined by the probability. Next part is, just a moment. Alright, so here we are going to discuss about the basic terms that we use in probability. So first one is the random experiment. Talking about experiment in simple words, what is an experiment? When you just do some activity, so that is simply an experiment. In probability, we use the word random experiment, right? Why we are calling it as a random experiment? First of all, we are not sure about the result of that experiment. We are not sure about the outcome. We cannot predict the outcome in advance. Second thing, we can have more than one possible outcomes out of that experiment. For example, you toss a coin, so you're not sure whether you're going to get head or you're going to get tail. So that is your random experiment. That is an example of random experiment. Then we have an outcome. In simple words, outcome is just the possible result of an experiment. So when you perform some experiment, you are going to get the result, and in probability that is termed as an outcome. Again, we can take the same example of coin, head or tail. These are the outcomes of the experiment called tossing a coin. Then we use the term sample space. So sample space is basically your set. It is defined as a set named, you can name it as S, capital letter S. This will hold all the possible outcomes. So this is the set of all the possible outcomes of a random experiment. So here I have taken the same example. When you perform the experiment of tossing a coin, that is your experiment, random experiment, and what possible outcomes are you going to get? That is head and tail. So we have listed those outcomes in a set. That is your sample space, and each element in that set, it is known as the sample space, or in a sorry, this is known as the sample point. Each element in the sample space, it is known as the sample point, or in other words you can say each outcome is your sample space, sample point, sorry. Next, talking about event, how do you define an event in the probability? So it is a kind of subset of the sample space. So we know sample space is a set, and if we consider any subset, that becomes your event. Or putting that in other words, we can say if we are interested in one particular outcome. For example, if I'm just interested in finding what is the probability of getting head, I can mention it like that. What is the probability of getting head? So that is my one event. If I'm interested a subset of the sample space associated with random experiment. Further, probability values, they can be defined as a fraction. We can write the probability as a fraction. We can also mention the probability in terms of percentage, as this is representing the possibility of an event, right? Or we can write the answer in decimal, but mostly we write the answers in fraction. We calculate the probability in fractions. So talking about the events here, as you can see on this number line, starting from 0, that shows the lowest value of probability, and all the way going up to 1, so that shows maximum value of the probability. Now here one event is mentioned, that is impossible event. So we can say for impossible event the probability value is 0. But now what is impossible event? We can define that event. For example, I have 6-sided dice and I'm trying to find out what is the probability of getting 7. So I'm not going to get 7 no matter what, right? When you throw 6-sided die numbered 1 to 6, there is no chance that I'm going to get 7. So that kind of event is your impossible event, and the value of that probability is 0. Value of probability of that event is 0. And now coming to certain event, it is very much clear from the name. Certain event, that is sure to happen, or we can say it has 100% chance of occurrence, and the maximum value is 1. For example, if I say the sun will rise in the morning, so this is sure to happen, right? This is kind of certain event, and the probability value is 1. Now with this we can conclude that probability of an event, it lies between 0 and 1, including 0 and 1. It cannot be less than 0 or it cannot be greater than 1. So maximum value of the probability of event is going to be 1. Now talking about the value which is in the middle, in between 0 and 1 we have 1 over 2. So 1 over 2 means 50%. So here we have those kind of events which have 50-50 chances of occurrence, or 50% chances of occurrence, and they are known as equally likely events. Equally likely events. That means they have equal chances of occurrence. Let's take the example, same example here. Experiment of tossing a coin. So there are two outcomes. We can say there are 50% chances that head is going to occur, or there are 50% chances we can get tail. So these kind of events, they are equally likely events. Now for the events whose value lies between 0% and 50%, let's say the chances are even less than 50%, those kind of events we can say they are less likely to occur. So value lies between 0% and 50%, or somewhere in between 0 and 1 over 2. Same way, if we have the event whose value is at least greater than 50%, or it lies between 50% and 100%, so they are more likely to happen, because you see the possibility is at least greater than 50% and it can be more closer to 100%. So these are kind of more likely to occur. Next we have the definition. How do we actually calculate the probability using this formula? The probability of an event, that is defined by this ratio, number of favorable outcomes divided by total number of outcomes. So we'll try to understand the formula here. For example, if you throw a dice, so first of all we can write the sample space. We know that the sample space S, we can put up all the possible outcomes here. So these are the all possible outcomes. We are going to get 1 or 2 or 3 or 4, 5, 6, right? So total number of outcome is 6. Now, if I'm trying to find out what is the probability of getting 2, so I can define that event as P of 2, probability of getting 2. So if you look in the sample space, this is my favorable outcome. I'm just interested in finding 2, probability of getting 2. So just one favorable outcome. So probability becomes 1 over 6. That's how you calculate the probability. Let's take another example of tossing a coin. If I am trying to find out what is the probability of getting head. So in that experiment, we already know the total outcomes are 2 and favorable outcome is just 1. If you can recall the sample space, we have head or tail. So this is my favorable outcome divided by total outcome. So 1 over 2 is the probability of getting head. If you convert that into percentage, it is 50%. Same way, if I write what is probability of getting tail, I'm going to get again 1 over 2 or 50%. So that will calculate the probability. Okay, that is just the formal definition of getting probability. So probability of any event A, that is defined by PA, that is equal to the number of favorable outcomes which are favorable to A divided by the total number of outcomes in the sample space. So same thing, this is the probability of an event. Okay, let's just consider some more examples. Heads. Now we have been talking about that example where we just toss one coin and we have two outcomes, either head or tail. Now here we are tossing two coins together, right? So what are the various combinations that we can get? For example, both heads can appear, head on first coin and head on second coin, right? Or we can have both the tails on two coins. What can be the other combination? Head on first coin, tail on second coin, when we toss two coins together. So here we have made this sample space, head head, head tail. Possible outcomes is 4. Now what is our event? Getting two heads. So if you look in the sample space, this is the favorable event, only HH. So the probability becomes 1 over 4. That's how you calculate the probability. Next is probability of getting exactly one head. Again, you look in the sample space. Where do we have exactly one head? This is the outcome and this is the outcome. So, two favorable outcomes. So, probability becomes 2 over 4 or 1 over 2. We can always simplify the answer. Whenever we are writing the answer in fraction, we can write the simplest form. So with this, I hope you have got the idea how to calculate the probability, what is the probability and how to calculate it. Okay, lastly we can talk about one event, which is the types of events, mutually exclusive events. So two or more events, we can say they are mutually exclusive if the occurrence of one of the event prevents the occurrence of the other event. Let's just try to understand that in other words. If I simply say the two events that cannot occur at the same time. Okay, for example, okay, we have various events here. So we'll try to consider them one by one and we'll see whether they are mutually exclusive or not. So on a throw of die, getting 1 or getting 5. So when you throw a dice, either you are going to get 1 or you are going to get 5. Right? There is no chance that you are going to get 1 and 5 at the same time. So that becomes same way if we consider the example of getting a head or tail. So at one time you are going to get head, at the other time you might get tail, but there is no chance that you are going to get head and tail at the same time. So these are mutually exclusive events. the events which cannot occur at the same time. Then okay, let's just take this example. Event of getting an ace or event of having a spade when you pick a card from the deck of cards. So you see, when you pick a card, you might get ace. There are 4 aces, as you know, right? One of each suit. So you might get ace. Know that there are 13 spades. So when you pick a card, you can get ace or you can get spade. But what if you get ace of a spade, right? We know that there are 4 aces. So one is of club, one is of diamond, one is of heart, and one is of spade. So this is possible that you can get ace of a spade. Now what is happening here? You are getting both these events occurring at the talk about this example, getting a king or a queen. So either you can get king or you can get queen when you pick a card from the. So finally we can go through this example, how to find out the probability of mutually exclusive events. So we know what is the probability of getting 2 or 5 on the dice. So probability of getting 2, we know it is 1 over 6. Probability of getting 5, again it is 1 over 6. Total 6 outcomes and favorable outcome 1. Same for this probability of 2. Now either you are going to get 2 or 5. So we use this operation of addition where we have this keyword or. So we are going to learn about all these keywords in the upcoming sessions. We'll discuss in detail. So as of now, you can understand that when we add these two probabilities, getting 2 or 5, you will get this final probability of showing 2 or 5 on the dice. Alright, if you have any doubt, I'm open to discussion. Thank you.